Leverglucosan is a promising platform chemical, and in this video we are going to talk about how it can be produced by recyclable, non-toxic ionic liquids. The world is increasingly looking beyond fossil fuels. The environmental impact of petroleum-based materials and chemicals is pushing industries towards renewable alternatives. Lignocellulosic biomass, things like wood, straw, and agricultural waste, is one of the fastest growing renewable resources we have, and it can feed into a wide range of industries and materials. This is the heart of what we call the bioeconomy. When biomass is broken down through pyrolysis, the thermal breakdown of lignocellulosic biomass, one of the byproducts is leverglucosan, a form of anhydrous glucose derived from cellulose. This molecule has become an extremely exciting platform chemical used to make a variety of different products, from solvents, fuels, and to precursors like polymers. It can even be hydrolyzed back into glucose. Leverglucosan is a platform chemical with some serious potential. Despite pyrolysis being the primary industrial processing technique for leverglucosan, there are some concerns around the environmental sustainability of this process. It is highly energy intensive, operating at temperatures above 400 degrees. It requires large amounts of cooling liquid which can introduce pollutants into local water sources, and it produces toxic air. Pollutants including carbon monoxide and nitrous oxide. Exploring a wet chemical approach, which can be integrated into other processes, could present interesting advantages. This is where the ionosolve process comes in. Ionosolve is a biomass fractionation technique that uses ionic liquids to separate raw biomass into its key components: a cellulose-rich pulp, a lignin fraction, and a hemicellulose-rich ionic liquid stream. Ionic liquids are salts that are liquid under room temperature and are recyclable in this process. The question is, can we use this technology and diversify the output to anhydrous sugars? Our research focuses on producing leverglucosan directly from ionosolve processed cellulose pulps. We're using the pulps with the imidazolium-based ionic liquid to produce leverglucosan, which is then evaluated on yield and selectivity. The goal would be to integrate this process into the ionosolve process and produce a complete biorefinery. One key challenge we must face is making sure there's not too much water in the reaction, as the chemistry then goes sideways and produces 5-HMF instead. Getting the conditions right is everything. This is early stage work, but it represents a step towards a cleaner, more integrated biorefinery approach with much less waste and pollutants than current methods. Thank you for listening.